Now let's look at a situation where we need to find the x limit. Previously we've seen that we had the x limit, then we've worked out the z and obtained this, the probability. Now we are looking at a reverse situation where we have the probability and we are trying to look for the z or the x value, or the z first, that we're going to call k, and the next thing is that we're going to see how to work out the x value from our coming exercise. This is more of a reverse situation, as you can see from those three questions, and when you read on your textbook as well, where you clearly see that we already have a probability, but we need to know what were the limits or the coordinate. The first thing that you do when you read for A, for example, is to sketch what you're being asked for. So let's find K such that P is 0 less than the Z, this less than the Z and less than K. Always a good idea to start by sketching, because you would have a clearer idea of what you're being asked for. For that, so we know that your mu is 0 because we're working with a standardized table, and we know that 0 is less than z, so your probability is less than that k limit. So this then will be okay, which I'll choose a different color, right? And your k obviously is equal to z because it's this limit here. And the value for this, we already know, we have here 0.3461. Then what you need to do is simple. Now you just go on the table and find this value or its closest value here and get the coordinate. So 0.3461 should be where exactly? If you have a good eye, it shouldn't take you longer. And so you have this. So what's that's telling me is that my k is equal to 1.02, since p of 0 less than z less than, now it's 102, is equal to this. Pretty much that's how you do that. Quickly now, let's go and look at our second question. Clean. Second question, now we need to find k under this condition. The first thing that I do is that I sketch. After I sketch, I put my mu first, and what they're telling me is that my k is less than z and my z is less than 0. So from what I see now, we see that everything is happening on this side of 0. So this side here. This one was happening on that side, if you noticed. Now let me point out my k first, telling me that my k is somewhere here, I would guess. So my k is less than z, so this area, and this area is also less than 0. So more or less, when you're dealing with this, just look at, if everything is happening on this side, then you know it will be on the positive side, and if 0 is here, everything is there, then you know that you'll be dealing with the negative side. That will be a quick trick on how to do that. Therefore, you know that your z here is equal to k, obviously, because it's the limit that that will determine all this probability here. Same thing, all you have to do is now go and find this number here. Perfect, this is here. Then you have 0.4 and 0.002. Therefore, you tell me that your K is minus, don't forget the negative sign, minus 4.2, and for P of minus 0.42 less than Z less than 0 with this number. Easy. Our third scenario C, let me first sketch it. Always remember your axis should never touch. What I see here is that your probability is greater than K. And you get this. The first thing I'll see is that my probability should definitely be something higher, because the sum here, if this is 0.5, this is 0.5, and everything is equal to 1, and I have a 0.8, I can see that my Z is quite a higher value. But what I would do, you'd first draw your K, because they say that your Z is greater than your K, which means that your limit should be on the lower end here. So if this is your K and your Z is greater than your K and is equal to 0.8, then you can see that your Z is covering about 80% of the curve. I hope that makes sense to you, because they're telling you that your Z, if this is your Z, obviously, is greater than this limit. You can see that from what I've just represented there. And now, in order to find this K, we need to be cautious of something. That we already know that this entire section is 0.5, right? So what we have to split now is we need to figure out this one from 0 here to this K, because we already know this 0.5. So the way we will split it is, first we write our area. Now I'm gonna subtract, because we cannot find the 0.8 here, remembering that our table only gives us the half probability because it's symmetrical. So I'm gonna subtract first 0.8051. I'm gonna subtract this 5, this one, just write all the zeros there, and which will give me a value of this. And now this is the value that I'm going to find here on this table. Looking for it, let's see, 0.351. We'll look for the closest one. 305. Okay, I see it actually. So 0.8. So I see that we have our value here. So it ended 0.86. Now I could say that my K is equal to minus, always remember the sign when you're dealing with the left side, minus 0.86. Then my probability will be now Z is greater than minus 0.86, should give me 0.8051, telling me that was 80% of all the Z values lie above that limit, which is almost what I said. Now let's move on to example 5.7, which is also on your textbook. Just take some time to read the question and come back. If I have to translate what we're being asked, in our first section A here, they want us to find the minimum, that X is the minimum amount that the highest spender, or spending 15% actually would want to pay. So that's the minimum amount that this highest spending group of people would want to pay in that store. First thing is always sketching, because it gives you a better idea of what you are looking for. If you mean here is 244, and we are looking for our x here, or which is also our k. Okay, and we know that the probability here is 15%, also written as 0.15. And because this entire thing is 0.5, if you do 0.5 minus 0.15, you know that here you have 0.35, which is here. And the line here is asymptotic, so we know that this can go on and on, but we are certain and sure of this area here. That's the probability. You understand that? This is the probability 0.35, and we're looking for this limit. So our best bet to find will be to figure out the probability between here up to here, the limits here, to get this x or this k. This will be done by our second step, which is the conversion. From our conversion, what do we know? We know that z is equal to x, the mu divided by the standard deviation. Now we are solving for x. Let's first get our k, or our z. Yeah, we'll call it z now, because it's more or less the same. So I'm going to go on the table and look for 0.345, or the closest value here would be, I'll go for 1.0, I would say 4. The reason why I'm going there, because it's the closest value to 0.35. And now I know that I'll say that my z is equal to 1.04, like what we've been doing with our previous exercise. Now I can rewrite everything 0.4. I don't know why I wrote 5 there. It's a 4 here. So 1.04 is equal to x minus 244, and I'm going to divide that by 68. Therefore my x will be equal to 244 plus, or just say 1.4 before I get to 70 there. I'll get to now 1.04 times 68, which is equal to 244 plus 70.2, which is 314.72 rand. So what that's telling me is that the minimum amount that the highest spender on this store would pay is 314.72 rand. So that the minimum purchase transaction of this highest spending 15%. So if this is our limit, what we've just found here, so we had a z of 1.04, which translates to this x of our 314.72. As you can see, this is the 15%, and this is the minimum amount that these guys can spend. Our second question now, they're asking us here if I can translate. It's more of the highest amount that this lowest spending group would pay on this clothing store. if I can put it in other words. We will begin by sketching. Our mu is equal to this. And now we are looking for the lowest spending. Your bet is already that we're going for this negative section, and we know that here you would this is where you would put the lowest spending. So if this is the limit, because we had our highest spending there, and we want to know what is the value that separates the lowest spending from the remaining customer, or also the highest amount that these people can actually spend in a store. 20% can be written as 0.2, and if you do that minus 0.5 minus 0.5, you get here 0.3. Then you know that that's the probability here, and to get my k, I would use this one. Let me look for 0.3, or the closest value to 0.3 here will be here, and I'll get 0.2995, so which is the closest value to 0.3 there. Therefore, I will write that my k is equal, don't forget to minus, say, your z. Sorry, I always keep saying k. Now it becomes your z minus 0.84, and you know your other values. Therefore, I'll write this way. You know the formula already. 0.84 then is equal to x minus 244 divided by 68, which will be equal to x is equal to 244 plus minus 0.84 times 68. I'll close equal to 244 minus 57.12, and giving me an amount of 186.88. In other words, this is here. Okay, so the highest amount, or the money that separates the lowest spender from the remaining, is 186.88. So this is the highest amount that this 20% group can spend. So you can see our Z, which is here, our Z is equal to minus 0.84, therefore is also equal to 186 rand.